Alright, hello everybody. Welcome to the homework help video for chapter 521. I'll be going over problems 45 through 55. So this is going to be 2 nights worth of homework in one video. So we're going to get started. Alright, looking at 45, it says for a line passing through the points -2, 1 and 2, -11. It says to calculate the slope of the line and find the equation of the line. So this is some old stuff that you guys should be fairly familiar with. The first thing we want to do is find the slope of the line for A. We know that for our slope, we're really looking for our change in y over our change in x. So how we've been representing that, change in y over change in x, is really just y2 minus y1 over x2 minus x1. Be careful, the thing that people get wrong most about these problems is they're going to switch their x and their y. Make sure your y's are on top. So when we plug that in, we're going to get -11 minus 1 over 2 minus -2. The top is going to simplify to -12, and our bottom is going to simplify to +4. Alright? When we do minus and negative, we're really just adding. We're going to want to simplify that. We know that -12 divided by 4 is going to give us -3. So our slope of the line will be -3. Then in part B, it wants us to find the equation of the line. So for that, we have to think back to our really important equation. It's called y equals mx plus b. So what we're going to need to do is we know a point, we know an m and we know our x and y, and we know our slope because we just solved for it in part A, which was -3. So really what we're interested in finding is we need to know what b is. So to do that, we're going to pick one of our points. I'm going to pick the point 2, -11, and that's the point I'm going to be interested in working with the whole time. So for my equation, my y is -11 is equal to my slope, -3, times x, which we know to be 2, plus our unknown, which is what we're solving for, b. All right? So when we do that, I'm going to write down in the space below. We find out that -11 is equal to -6 plus b. We're going to add 6 to both sides. And so b is equal to -5. So then we can take it and plug it back into our equation. So what we're looking for in b, where it says to find the equation, we're looking for y is equal to -3x minus 5. Moving on to 46, it says that Allie is making 8 dozen chocolate chip muffins for the food fair at school. The recipe she's using makes 3 dozen muffins. So the original recipe, which we know makes 3 dozen, calls for 16 ounces. We want to know how many ounces of chocolate chips does she need. All right, so some really important information, hopefully you're picking up, is 3 dozen, 16 ounces, and 8 dozen. So that's part of our known information. With this, we're interested in setting up a proportion. And so proportions allow us to think and make things equal to each other. So first we need a fraction for what is known. One of the things that is definitely known is anything in the recipe. So we know that the recipe makes 3 dozen, and the recipe calls for 16 ounces. So those are the two pieces of information that have to go together. We know that there's a relationship between the amount a recipe can make and how many chocolate chips it calls for. So we're going to say number of chocolate chips and how many of dozens. I'm going to call this C and this D. And so we set up a proportion for our recipe. We know the recipe need 16 ounces for 3 dozen. So this is a really important one. This is one you should definitely have together. All right. So we're interested in putting this up into a proportion. So we know that 16 over 3 is going to be equal to. So we've kept number of chocolate chips on top. And that's what we're asked to solve for, right? We want to know the number of chocolate chips she needs to buy. And then we want to make 8 dozen. So once you set up your proportion, we just need to cross multiply and divide. So we're going to cross multiply 16 times 8 and then divide by 3. So 16 times 8 is going to give us 128. So we'll have 16 times 8 is equal to 3c. 128 is equal to 3c. So we'll divide by 3. We get c is equal to 64. And so we're going to need 64. Let's double check our math to make sure that works. So we've set up this relationship now that says 16 over 3 is equal to 64 over 8. So I'm going to do 16 divided by 3, which gives me 5.3 repeating. And then my 64 divided by 8, which gives me 8. Oh, I've done something wrong. Let me go back and double check that. So I should have done 16 times 8 divided by 3. Oh, I divided by 3 wrong. So when we had 128 equal to 3c, we should have gotten 42.6 repeating. My bad. Good thing I double checked my work. 42.6 repeating. So we know that she needs to buy 42.6 ounces. It says that Allie buys her chocolate chips in bulk and can measure them to the nearest ounce. So we want to make sure we're rounding that up, is what that question is telling us. So instead of 42, we want to round up to 43 ounces. All right, moving on. We're going to look at 47. So I'm going to erase and move down. All right, so in 47, it says that the area of a square is 225 square centimeters. And that tells us to make a diagram and determine the length of each side. So we have a square, a perfect square. And we know that inside it's 225 centimeters squared. So what you want to think is that when we're trying to find the length and the width of each side, we know that the length times width is going to be equal to the total area. And one of the special properties about a square is that the length and the width are going to be equal to one another. So that tells me I can do L times L or W times W. So we've got L squared is equal to 225. So we're gonna undo the square by taking our square root. So the square root of 225 gives you 15. So that you know each side is 15 centimeters long. And then it asks us to use the Pythagorean theorem to find the length of its diagonal. So to do that, redraw it. We know that the length is 15, the width is 15, and we're interested in finding c. So we know a squared plus b squared is equal to c squared. So when we plug that in, 15 squared plus 15 squared is equal to c squared. 15 squared twice added together is 450. That is equal to c squared. And then we want to take the square root of that. So for this one, we're looking at the square root of 450, which we're going to round to about 21.2 centimeters. One of the things we should keep in mind is that we know that that diagonal needs to be longer than the length and the width, which it is. Excellent. And so we've used our Pythagorean theorem to find it. All right, moving on to 48. It wants us to refer back to problems C and I. How are these sequences similar? The numbers in the sequence in part E, problem 4, are called the Fibonacci numbers. All right. So they just want to call our attention back to those sequences. We did that one in class, so I'm going to go ahead and skip that one. If you still have questions, feel free to come and see me. But we talked about those in class today. All right. So then I'm going to jump down to 49. It says that Chelsea dropped a bouncy ball off the roof while Nuri recorded its rebound height. The table below shows the data. Note that 0 is the bounce column, represents the starting height. So, what family does the function belong to? Well, for this one, maybe we want to graph it and see what it's going to look like and explain how you know. So we don't have an equation for it. All we have is the data. So show the data as a sequence. Is the sequence arithmetic, geometric, or something else? So we're interested in finding out if there is a common, with arithmetic, either it's being added by a constant, geometric, it's being multiplied by a constant, quadratic, we know it has a symmetry around its vertex, or something else. And so with this one, we might want to plot the points. I think what I'm going to do is come back to that one. What I would suggest you do is you'd either take in your graphing calculator and enter in those points, or on a separate sheet of graph paper, you go through and you plot them and see what the picture is telling you. I think you guys will be very good at looking at the graph and determining what type it is, okay? If you still have questions about that one, come and see me, but for that one, I would say just graph it, graph it, graph it. All right, 50. They tell us that f of x is equal to the square root of 3x minus 2, and it says to find the value for each expression below. So all we need to do is plug in. So we're in A, wherever we see an x, we need to plug in 1, right? So with this one, it could be as easy as taking it to your graphing calculator. So that is what I'm going to do. So in my graphing calculator, I'm going to put in the equation that they gave us. They said the square root of 3x minus 2. Let me just double check to make sure I do everything correctly. Excellent. All right, so we need 1, 9, 4, and 0. So we need very specific ones. So I'm going to change my table setting from auto to ask. I'm going to ask for the independent or the x values. When I go to my table, I'm going to find 1, 9, I think it was 4, and 0. Yes. So if you solve it by hand, or if you take it to your graphing calculator, the answers that you should get is that for f of 1, our y is 1. For f of 9, we should get 5. F of 4, we need to get some type of decimal, 3.1623. So if you round that one to about like 3.1, 3.2. And then for 0, we get an error. So let's find out why that's happening. That sounds like an interesting one to look at together. So what we want to do is we're going to plug it in. And so we will have, for f of 0, the square root of 3 times 0 minus 2. We know that 3 times 0 is just 0. And so we're really left with the square root of negative 2. And what we should be seeing is that we cannot take the square root of a negative number. Remember, when we take a square root, we're looking for the two numbers that multiply together to give us that number under the radical. And there's nothing we can multiply to get negative 2. For that, we're either going to have two negatives or two positives, which won't give us a negative. And so there's an error because of that negative sign under the radical. Finally, it says, what value makes f of x 6? So if we're using our calculator, what we can do, I need to erase that off the screen, is I'm going to put in my equation y. We're interested for where y is 6. So I'm going to make a separate equation that says y is equal to 6. That's going to draw a straight line, and I'm going to see where it intersects with that data. So let's zoom 6 standard and see what we get. So our original function is in blue, and then our y equals 6 is in red. looks like I need to change the window a little bit to see where they will intersect. So I'm going to change my window. I'm going to have my x start at 0 and go to 20 and see if the answer is between 0 and 20. So there's my function, the square root of 3x minus 2. And then, beautiful, looks like we've got an intersection point. So I'm going to take and, whoops, I need to calculate the intersection, which is 5. So I'm going to get over on my calculator. I want to get it as close to where I think the red and blue lines touch as possible. And it says that I've got an intersection point at 12.6 repeating. So the answer for where it is equal to is 12.6 repeating. We can do this using our graphing calculators. You're also able to solve it by hand. So let's go back and try and solve it for you algebraically. Probably the way you solve it is you said 6 was equal to 3x minus 2. First we want to get rid of that radical, so we're going to square both sides. So we get 36 is equal to 3x minus 2. We'll add 2 to both sides. 38 is equal to 3x, so we'll divide by 3. And we'll find out that x is equal to 12.6 repeating. So you can do it both using your graphing calculator or by hand. All right, moving on to 51, some of the newer homework. This is the one that was just recently assigned in class today. In 51, they asked us to simplify each expression below. So for this one, they want us to realize that this is 1y plus 0.03y. So really what we have is 1.03y. In B, we're subtracting, so we've got 1 whole z, and we're taking away 0.2, which means we'll be left with 0.8z. And then in C, we've got 1x, and we're adding 0.002. So it's very much like part A. And so hopefully you were able to combine those. All right. 52. 52 says that a tank contains 8,000 liters of water. Each day, half of the water in the tank is removed. How much will be there after the end of the 4th day and the 5th day? So this one, probably the way that it'll be easiest for you is if you start setting up a table with an x and a y. So we'll let x represent the number of days it's been, and we'll have y equal our number of liters that are left. So to start out with, on day 0, we have 8,000. After the first day, we're going to take half of it, tell us that half of the water is left. So if we started out with 8,000, the next day we'll have 4,000. By day 2, we'll have 2,000. So again, we're just taking and dividing by 2 or multiplying by 1/2. Day 3, we'll have 1,000. Day 4, which is what we're interested in, we will have, if we take this in half, 500. And we can keep going on and on and on and on, following that pattern, taking a half each time. Another way we can do it is if we're interested in taking it to the next step, is thinking about creating an equation and solving an equation. So a table is an excellent way to solve it. Hopefully you were able to think of that one. Also, what we can do is write an equation and solve our equation. So to do that, we need to know our starting number. So we know we start with 8,000 liters. And then what are we doing? Well, we're taking and dividing it by half, or really multiplying by 1/2 each day. So the equation that I want to set up is that y is equal to 18,000 times 1/2 to the x. So when I throw that into my graphing calculator, y equals, and I'm going to clear my previous equations, 8,000, our starting value, times that thing that we're doing over and over and over again, which is repeating 1/2, and then, oops, not squared, sorry, to the x. All right. So then when I take that to my table, I'm interested in the 4th day, which I believe was 500, and our 8th day, which gives us 31.2. So on the 4th day, there will be 500 liters, and on the 8th day, there will be 31.25 liters left. All right, 53 is a good old solve the system. Hopefully these are becoming really easy for you. With more and more practice, these are going to keep coming back up, especially in Algebra 2, but you'll see you'll be tested on it more and more in Algebra 1. So please make sure that these are making sense. I would say by now, if you're still struggling with these types of problems, please come and see me for extra one-on-one help. All right, 54 tells us to draw a slope triangle to find the equation of the line shown below. So with our slope triangle, we're interested in our rise and our run. So we're going to be going down and then over. So we're going down from 500 to 130. So we've gone down 20. And we've gone to the right from 2 to 4. We've gone 2. So we have a slope of -10. And then we're also interested, if we want to find the equation, in where x is equal to 0 or our y-intercept. So it's not quite easy to see, but we know that it should be more than 50. Looks like it goes up by 10 each time. So it looks like we're looking at the equation y is equal to our slope, -10x, plus our starting value, which looks to be about 170. And again, for the slope triangle, really all they're asking you is, can you determine the slope given the 2 points? Looking at it on a graph and seeing if you can find it. If you need to set it up using your change in y over your change in x, that's also fine, because you can do that while looking at the graph. All right, 55. So this is our last problem. This is a checkpoint problem. We are not going to be doing a specific checkpoint quiz right away. You will see this, though, probably come up on the next quiz or test. So we want to simplify each expression, e through f, write in e through f, and then write the final answer in scientific notation. All right, so everything in parts e through f should be in scientific notation, but a, b, c, and d do not need to be. So let's go ahead and do these. So with this one, we're really looking at, well, what does an exponent mean? So really what we have is 4 times 4, and we're multiplying that by 4 times 4 times 4, 1, 2, 3, 4 times 4. And so what we really have here is 4 to the 7th, right? We've got 7 of those 4s being multiplied together, and then if you want to take it to the next level, 4 to the 7th is probably a huge number. My calculator says it's 16,384. In B, you need to understand your order of operations. That being, you need to take care of what's inside the parentheses first. All right, and then a special one, kind of a special property is anything to the 0 power is 1. If you were to put this into your calculator, 5 to the 0, you would get 1. So we have 1 to the 3rd. 1 to the 3rd is just 1 times 1 times 1, which is equal to 1. In C, we've got a negative exponent, and what you should be thinking when you see a negative exponent is you need to flip it. If your negative exponent is in the numerator, that means everything needs to go to the denominator. So we're really looking at 1 over x times x times x times x times x. And then we're multiplying that by x times x times x. What we really have is y to the 3rd over y to the 5th. We're interested in canceling out anything they have in common, and so we can see that we've made some pairs, right? So for every 1 in the top, I can cross out 1 in the bottom. And what I'm really left with is 1 over x squared. All right? And then part D. In part D, we've got some negative exponents, we've got order of operations, we got a whole mess going on. So let's take care of some things. With this one, I'm just going to show one way, but you might have done it a different way. Just make sure that we get the same exact answer, okay? So for D, we've got x to the 1/2, or sorry, x to the -1. We talked about anytime you see it in the numerator, you need to flip it to the denominator. And then from there, we are multiplying it 5y squared. And it's to the third. So we're going to take that third, and it has to go into everything. So we're going to give third to the 1, we're going to give 3 to the x, and 3 to the 2. So what we really have is 1 over x times 1 over x times 1 over x times y times y times y. So what we're left with is 1 over x cubed times y cubed, or you could also write it as y to the third over x to the third. With that one, if you wanted to wait to save it till the end, putting it over, you could have done that as well. All right, D. Now we need E and F, which need to be in scientific notation. All right. So this, I'm not exactly sure how you first were introduced to this. I'm just going to do it one way, and if you want to come in class and kind of tell me how you've seen it done before, that's fine. What I like to do is for the first half, I like to pretend that this 8 and this 1.6 aren't there. I'll take care of that later. Right now, I'm just focusing in on my 10 to the 5th times my 10 to the negative 2. This is just like what we were doing with variables. We know we have 10 times 10 times 10 times 10 times 10 over 10 times 10. And we know that wherever we see a match, we can get rid of it. 1 on the top, 1 on the bottom. So we're left with 10 to the third. So what that means is we're going to take our 8 times 1.6, bringing that back into the equation, which we know is going to be 12.8 times 10 to the third. And the one thing about scientific notation is we only want one number in front of the parenthesis. I know I'm going to need to move this to the left, so what we'll have is 1.28 times 10 to the fourth. All right, and then in F, same deal. I'm going to wait to do 4 divided by 5 till the end, but really what we have is 10 to the third over 10 to the fifth. We know that we'll have 3 in the top and 3 in the bottom, so when we cancel out what they have in common, this leaves us with a 1, and this will leave that with a 3, so we'll have 1 over 10 to the third. So what we get, we'll do 4 divided by 5, which is going to give us 0.8 times 10 to the third. I'm going to bring that up to the numerator, so this is going to become times 10 to the negative third, and I want this 8 to be in front of there. I moved my decimal to the right, so we're going to become more negative, so we've got 8 times 10 to the negative fourth. Hopefully these are becoming a little bit easier for you to do. If you still have questions about them, though, please feel free to come in and talk to me. I know scientific notation can be kind of tricky, and it's something we need to learn over and over again. So if you have any questions, please feel free to come see me. But that concludes the homework help video. I hope you found it helpful, and I will see you in class tomorrow. Have a